Let's talk about the now SSD versus the HDD. So I think that most of you now familiar with SSD, the solid state drives. So SSD is it's based on the transistors and the capacitors. So meaning that there are no more moving mechanisms, no more hard disk, no more the reading and writing hand, etc. Okay, it's not a mechanical device anymore. With this magnetic disk, this is a uh, partially mechanical device because you have the so many moving parts. Okay, with SSD, no more moving parts. It's just a chip, small chip. So that's why it has a better performance, right? So the speed is much more faster, more durable, longer lifespan, and of course the lower power consumption, much more quieter, and lower access time and latency rates. Okay, so this is the comparison between the SSD and then the HDD. So as you can see, the speeds are much more faster. So this is a bit manned flash drives. Nowadays we have the even more faster NVMe, etc. They even write in a gigabytes per second. So in this case, the gigabits per second. So this is in a megabits per second, but still much more faster compared to the HDD. Less power, right? And then the size is actually compared to the storage capacity is lower compared to the HDD, of course, right? So this is one of the drawback, and price is much more expensive compared to the HDD. So the SSD is faster, uh, have the better performance, right? So low power consumption, but the capacity wise it's still smaller compared to the same size HDD, and also the price is much more higher in terms of the SSD compared to the HDD. And this is how the SSD organized internally, right? So you have some interface, controller, addressing, and then you have the bunch of the flash memory components. So when you look at the top of the SSD, you will see there are a lot of small black chips. So each chip is actually the flash memory component. So what are some of the issues SSD that are not faced by the HDD? So the SSD performance slow down as the device is used. So after some time, usually the SSD will slow down. And then when you read or write from the SSD, entire block must be read from the flash memory and placed in a RAM buffer. So you cannot read or write in a bit level or the byte level. You have to read in a block level. Before the block can be written back to flash memory, the entire block of flash memory must be erased. Okay, so first you erase the whole block and then write on the top. Okay, again the entire block from the buffer is now written back to the flash memory. Okay, so these are some of the drawbacks. And the flash memory becomes unusable after a certain number of writes. So meaning that the SSD and the flash memory have the reading and writing time. So how many times you can actually write it or read from the flash memory. After that, it becomes the unreadable or unwritable. You can read, but you cannot write. Okay, sometimes. So how to prolong front-ending the flash with a cache to delay the group and write operations, using the wear leveling algorithms, a bad block management technique, etc. So these are some of the techniques that are used by the manufacturers or the OS, for example, your computer operating system or your Android operating system to extend the life of the SSD. So the most flash devices, they can estimate their own remaining lifetime. So system can anticipate failure and take some preemptive actions.